Hello, welcome to my ham radio tech course for the 2022 through 2026 question pool. My name is Rodney Biddle and I will be your narrator for this course. This particular video covers question pool T1, section T1B, Commission's rules, covering frequency allocations, emission modes, spectrum sharing, transmissions near band edges, contacting the International Space Station, and power output. This video covers 12 questions that are in T1B. This presentation is based on the layout of the questions and content from my own book, Biddle's Ham Radio Study Guide, Technician Class 2022 through 2026. This book covers the 411 questions plus additional content such as radio tips, repeaters, power planning tips, choosing a radio, and more. Okay, our first question in this grouping, T1B01. This is a new question. The N beside the question ID indicates a new question for the current pool, or for the new pool. Okay, which of the following frequency ranges are available for phone operation by technician licenses? A, 28.050 megahertz to 28.150 megahertz, 28.100 megahertz to 28.300 megahertz, C, 28.300 megahertz to 28.500 megahertz, or D, 28.5 megahertz to 28.6 megahertz. Now, the key to this question is that we are looking for phone operation, not any other type of operation. Phone operation is voice operation, so you're just keying on the mic and you're talking. The answer to this question is C, 28.3 megahertz to 28.5 megahertz. Okay, so this is an important question to remember. As a licensed tech ham operator, you do have privileges on the 10 meter band, which is the only HF band that you will have access to. You will not have full access to the 10 meter band. You will have limited access within this frequency range. In the US, the tech will have access to frequencies from 28.0 megahertz to 28.3 megahertz for CW, RTTY data, and CW is also known as Morse code. The tech will have access from 28.3 megahertz to 28.5 megahertz for voice or phone operation, with voice or phone being the same thing. General license holders have full access to the band, which runs up to the 29.7 megahertz. The frequency range in the 10 meter band that you will have permissions to is for AM modulation only, not FM modulation. With a proper AM 10 meter radio using single sideband, you will get radio ranges often up to 50 miles without the use of a repeater, far greater than you will normally get with a 6 meter, 2 meter, or even 70 centimeter bands. Some operators use the SSB and at proper propagation times can make long distance contacts far greater than 50 miles. Now, this is communication without a repeater. So we're doing direct radio to radio communication. So for a tech, this is going to be the band that will offer you the most range. However, it does require a special radio that supports AM or AM SSB operation. Most of your handheld radios and your mobile radios are going to be UHF and VHF only. So our next question, T1B02. Which amateurs may contact the International Space Station on VHF bands? A, any amateur holding a general class or higher class license. B, any amateur holding a technician class or higher license. C, any amateur holding a general class or higher license who has applied for and received approval from NASA. Or D, any amateur holding a technician class or higher license who has applied for and received approval from NASA. The answer to this is B, any amateur holding a technician class or higher license. As a technician, a license holder, you will have the ability to communicate with the ISS on VHF and UHF frequencies. In the US, VHF is primarily used using the frequencies of 145.800 megahertz for downlink and an uplink frequency of 144.490 megahertz. The ISS also has a simplex UHF frequency of 437.550 megahertz, though this is not frequently used. Reaching the ISS on VHF or UHF bands may require use of special directional antennas, such as a Yagi or dish antenna. We'll get into the Yagi and dish antennas later, but a directional antenna will give you a boosted signal in one specific direction where you would point the antenna towards where the ISS is. Also, on the original questions, two things to remember. First, you're taking the tech class, so that means you will have access to communicate to the ISS legally. So the questions that refer to requiring a general license are not true. That's one way of remembering that. And also, you do not need any special authorization from NASA. So remember that you don't need any permissions from NASA to try and communicate with the ISS. Whether you'll catch someone or not is a different matter, but you do not need any special permissions from NASA. Okay, our next question, T1B03. Which frequency is in the 6 meter band, amateur radio band? A, 49.0 megahertz, B, 52.525 megahertz, C, 28.5 megahertz, or D, 222.15 megahertz. So this is a case in which you're going to need to know the different bands and the band ranges. You don't need to know exactly what they are, but you do need to know generally what they are. The answer to this is B, 52.525 megahertz. Okay, the 6 meter band has a VHF frequency, is a VHF frequency, which sits between 30 megahertz and 300 megahertz, meaning that the VHF band is between 30 megahertz and 300 megahertz. If you remember what range the VHF is, and this rules out one of the options immediately, which is 28.5 megahertz. That 28.5 megahertz happens to fall within the HF band. Others can be ruled out if you can remember that the 6 meter band starts at 50 megahertz. So that's going to rule out 49 megahertz as being too low and out of the band. And 222.15 megahertz is also far too high. The 6 meter band runs from 50 megahertz to 54.0 megahertz. So on this question, try and remember that the 6 meter band starts off at 50 megahertz. If you can remember that, that should help you with the question on the test. T1B04. This is a modified question, thus that's the reasoning for the M. Which amateur bands include 146.52 megahertz? So this is a single band. So which amateur band includes 146.52 megahertz? A, is it 6 meters? B, 20 meters? C, 70 meters? Or D, 2 meters? Our answer on this is D, 2 meters. So this is another example of where you need to know where your frequencies fall, which bands they fall between. 146.52 megahertz is known as the simplex calling frequency for the 2 meter band. The calling frequency is the frequency you can set your radio to if looking for someone to reach in an area and you know of no other frequencies. This is a universal frequency to call out on for 2 meters. Simplex, which means you're not using a repeater. Simplex communication is non-repeater communication. Other frequency bands have calling frequencies as well. These are 70 centimeters, which has a 446.000 megahertz. That is going to be a popular one that you'll use with most handheld radios. 1.25 meters is 223.5 megahertz. 2 meters is 146.52 megahertz. 6 meters is 50.3 megahertz. And 10 meters is 28.385 megahertz. The two of these that you'll want to remember and try and memorize are the 70 centimeter and the 2 meter. Those are going to be the two that you'll most likely be using. Okay, question T1B05. This is a slightly modified question from the prior pool. How may amateurs use the 219 to 220 megahertz segment of the 1.25 meter band? A. Spread spectrum only. B. Fast scan television only. C. Emergency traffic only. Or D. Fixed digital message forwarding systems only. Our answer is D. Fixed digital message forwarding systems only. Okay, a fixed digital messaging forwarding system is also known as a digipeater, which is a device that stores and forwards digital messages. Amateur operators, including those with tech licenses, have approval to use these frequencies as secondary users, providing they are not interfering with someone considered a primary user. T1B06. On which HF bands does a technician class operator have phone privileges? A. None. B. 10 meter band only. C. 80 meter, 40 meter, 15 meter, and 10 meter bands. Or D. 30 meter band only. Our answer to this is B. 10 meter band only. So remember that 10 meters is the only band that you have any type of phone privileges on. Hams with a tech license have access to a portion of the 10 meter band. The 10 meter band for general and advanced extra license holders is between 28.0 and 29.7 megahertz. As a technician, your privileges are limited between 28.0 and 28.5 megahertz, with that being split for CW, which is also known as Morse code, RTTY, and data from 28 megahertz to 28.3 megahertz, and voice operation from 28.3 megahertz to 28.5 megahertz. As an HF band, the frequencies available will operate at longer distances and have propagation characteristics not available on the VHF, UHF bands. Technician operators will require an AM radio, not an FM-based modulated radio, for operation. Using these frequencies with the proper type of radio will allow communication ranges from 50 miles to much greater. This is also going to be the only frequency band or frequency range that you'll have access to that has some type of a good propagation capability. You might get some propagation with VHF, but it's going to be nothing great. T1B07, another modified question. Which of the following VHF, UHF band segments are limited to CW only? So what we're talking about is what frequencies can you only use CW or Morse code on? The options are A, 50 megahertz to 50.1 megahertz and 144 megahertz to 144.1 megahertz. B, 219 megahertz to 220 megahertz and 420.0 megahertz to 420.1 megahertz. C, 902.0 megahertz to 902.1 megahertz. Or D, all of these choices are correct. Our answer is A, 50 megahertz to 50.1 megahertz and 144 megahertz to 144.1 megahertz. All frequency bands have some levels of CW Morse code permissions. In some cases, some ranges are limited to CW Morse code use only and cannot be used for voice or phone use communication. In the 2-meter band, 144.0 megahertz to 144.1 megahertz is limited to CW use, while in the 6-meter band, 50.0 megahertz to 50.1 megahertz is limited to CW. On the test, this is going to be the only question that would be like this, where you're asked what limited range you have for CW. So the best thing to do is try and remember this. Try and memorize this question. How are U.S. amateurs restricted in segments of bands where the amateur radio service is secondary? This is question T1B08, and this is a modified question. So how are U.S. amateurs restricted in segments of bands where the amateur radio service is secondary? A. U.S. amateurs may find non-amateur stations in those segments and must avoid interfering with them. B. U.S. amateurs must give foreign amateur stations priority in those segments. C. International communications are not permitted in those segments. Or D. Digital transmissions are not permitted in those segments. Our answer to this one is A. U.S. amateurs may find non-amateur stations in those segments and must avoid interfering with them. Okay, so some frequencies and even some bands that are available to ham radio operators to use may have other uses which could take priority over the use of ham radio operators. For instance, the 60-meter band has frequencies which the government has priority to use. If a ham radio operator trying to use a frequency in the 60-meter band hears official communications from the government officials, they must relinquish use of that frequency and not cause interference. Other radio types have these restrictions as well. MERS, which is not a ham radio system, but MERS is also based on an older business radio system, and businesses have priorities to use those frequencies, all due to past licensing history. Next question, T1B09. Why should you not set your transmit frequency to be exactly at the edge of an amateur band or subband? Our options are A, to allow for calibration error in the transmitter frequency display. B, so that the modulation sidebands do not extend beyond the band edge. C, to allow for transmitter frequency drift. Or D, all of the above choices are correct. Our answer is D, all of these choices are correct. Okay, this is a little bit more drawn out of an answer, but for this question, the issue boils down to the bandwidth of the frequency when you transmit. See, the frequency you key in is the dead-on center and specific frequency you will be transmitting in. But your transmission takes up frequencies on either side of the transmit central frequency. On one side is the upper sideband, the other side is the lower sideband. If a wideband transmission, which uses 25 kilohertz wide channel with 5 kilohertz deviation, while a narrowband transmission uses just 12.5 kilohertz with a 2.5 kilohertz deviation. So note that digital modes such as DMR use 12.5 kilohertz wide band channels, allowing two channels to ride in the same transmission space as a single ham 25 kilohertz signal. This is part of the push to digital, where you can get more use of the same frequencies. So if you're communicating on a wideband channel on 148, which is 148 megahertz, which is the top edge of the VHF 2-meter band, then your communication actually is going to extend 12.5 kilohertz above 148.0 center of the frequency. So you are transmitting into the 148.125 megahertz, which is outside of the band, and you are now illegal. This explains why answer B is correct. As for A and C, these are also correct because even if you transmit at 147.875 megahertz, which would put you at 148.0 at the upper edge, if your radio has calibration errors or your radio has a transmitter frequency drift, you could easily cross the edge of the legal band. So the radios aren't perfect. Sometimes you'll have frequency drift or you'll have calibration errors that could take you outside. So you don't want to play on the edge. Okay, next question, T1B 10. Where may SSB phone be used in amateur bands above 50 megahertz? So SSB is single sideband phone, and single sideband phone requires AM modulation. So our answers are A, only in subbands allocated general class or higher licenses. B, only on repeaters. C, in at least some segments of all of these bands. Or D, on any band with if the power is limited to 25 watts. Our answer is C, in at least some segment of all these bands. So SSB refers to single sideband transmissions in frequencies above 50 megahertz. When you get your license, your most common radios being used will be FM modulated frequency or frequency modulated radios, which do not perform SSB or single sideband communications. SSB is a function of AM radio, which is used with higher end radios and performs very differently from handheld FM radios you may be using, such as your Baofeng radio or smaller handheld radios. All of the bands offer some frequencies where you're allowed to use SSB modes. SSB does have some advantages over FM in that it allows better use of the power in the radio and more opportunities for greater distance. The greater distances are usually through propagation, radio propagation. Something else is most of your radios, keep in mind your modulation types. Your Baofeng radios, most handhelds, and most VHF, UHF mobile radios are going to use FM modulation. SSB is tied in with AM modulation. AM modulation, SSB can be used in, it's very, very common, most popular in HF radio. So you're able to use it in any band above 50 megahertz, but not on all frequencies. Okay, our next question, T1B11. This is a modified question. What is the maximum peak power envelope output for technician class operators in their HF band segments? Okay, so we're talking about HF bands here. So A, 200 watts, B, 100 watts, C, 50 watts, or D, 10 watts. Our answer is A, 200 watts. Okay, so as a technician, you do have limits that do not exist as a general license holder. A technician can transmit at 200 watts on HF bands, and 10 meters is the only HF band open to techs. As a general license holder, you will have permissions to all of the HF bands, and you will have a maximum power transmission limit of 1500 watts. You must remember, as a tech, the 200 watt limit is for HF bands only. On VHF, UHF bands, maximum power levels of 1500 watts is allowed. You'll need to keep this difference in mind. 200 watts on HF, 1500 watts on VHF, UHF. Okay, question T1B12. Except for some specific restrictions, what is the maximum peak envelope power output for technician class operators using frequencies above 30 megahertz? Now, we have actually already had a variation of this question. So A, 50 watts, B, 100 watts, C, 500 watts, or D, 1500 watts. Our answer is D, 1500 watts. The limitation for 10 meters for a technician is 200 watts, which is the 28.0 megahertz frequency range, below 30 megahertz. This is something you need to remember. 200 watts for HF otherwise 1500 watts. And that is the end of this section.